Okay, so this is section 7.5, some more proportions and triangles that we want to know and some additional information. All right. So when parallel lines intersect two transversals, what are the relationships between the lengths of the segments formed? So that's one of the things we're going to be looking at. And so here we go. Here we have, if a line is parallel to one side of a triangle and intersects the other two sides, then it divides those sides proportionally. This is a segment inside the triangle. It is parallel to this side right here. It intersects the other two sides. When that happens, these pieces will be proportional. And just make sure you set them up in the same way. So, although this was small and this was large, it doesn't have to be. I could have moved this line way up here. Okay, so it's like this piece is to that piece. So, see the order in which I did it? And then I got to do the same order over here. So this piece is to that piece. See, this piece to that one, this piece to that one. Or I could have gone the other direction. This over this, this over this. As long as you go in the same direction, you'll get the same proportion when you're done. Okay? And note, we know that these two triangles that you see, this one right here and the littler one, are going to be similar and by angle. Okay? So, and you can explore that and why that would be true. Here's another one. This is called the mid-segment theorem because the segment that I'm drawing now is right in the middle of the triangle and it hits the midpoint of these two sides. So if I take a segment and I draw it to the midpoints of two sides of this triangle, then this segment will be parallel to this segment and it will be half the length. So if I have a segment that connects the two midpoints, this segment will be parallel to that and it will be half the length of that. Okay. So this is like one of the big ones. You want to remember this one a lot. You see that a lot. That happens on a standardized test because if it has an actual name, this is called the mid-segment theorem. Triangle mid-segment because there's another one later on for a different shape. So this is the triangle mid-segment theorem, and that's what it means. Connect the midpoints of two sides, and that segment will be parallel to the third side and half its length. So let's look at an example. So in this example up here, here's what I have written. Not a very good drawing, but you'll get the idea. We're going to try and find the X, the Y, and the Z from this picture. Okay? So how do I find this information? Let's take a look. So what we're doing here is we need to figure out some kind of relationships that we know to try and find the pieces that are missing. So if we want to start by looking for X, that's the best place to go. X is these pieces down here. Okay? And so what do I know about this kind of stuff? Well, I know that if I draw a segment that is parallel to the third side, which this one's supposedly supposed to be, then it cuts the pieces into a proportion. So because this is parallel to this side right here, then this piece to this piece, okay, ignore that this Y is here, is proportional from this piece to this piece. So let's write that out. So X is to 12, 9 and 3 is 12, as this piece, which is X plus 2, is to this piece, which is 16. And then I can cross multiply this, which gives me 16x, 12 times x plus 2. And then I can distribute. So this distribute and then move it over here. So I'm going to get 4x equals 24. And so x will equal 6. So there's that one. Okay. So then we can look some more and see what other patterns we can have. Since this is 6, I know this is now a 6, and this over here is an 8. So I know that to be true now. So I can use that knowledge then to help me find y. Okay? Take a look at what I know. Y connects 2 points on this triangle. Even though it's not drawn to scale, this length is 12. This length is 12. This length is 9. This length is 9. So it connects the midpoints of those two sides. So now I know that y is going to be parallel to this side down here. And I know it's half of its length. So y is 1/2 the length of 30 or 15. Okay? What is z? Okay? So a z just connects what? We want to find that length. So we have two similar triangles here, the big triangle and the little triangle where z is a part of it. Z is the bottom of this triangle that is similar to this triangle. So z is paired with, you pair it with the 30. Okay. I can do this side to z is this side to 30 is one methodology you can do. I have this side to z, this side to 30. So there's a lot of things I can do. So I can also use this little triangle because now I know it's also parallel. It's also similar. So there's so many things I can do here. Okay. So let's go find one and set it up. Now we know y is 15. So since I have, I think I did the smaller triangle first. So what I did is I went this side to y and then this side to z is what I did. So let's try that one. So 12 is to y, but y is 15. 12 is to y as 16 is to z. And that sets up a proportion for me. And then I can cross multiply. So I can multiply by that, divide by that. And z is going to be 15 times 16 divided by 12. And then that reduces down to 20. So that gives you one possible way of finding all of these values. Okay? So again, there were so many different possible ways of finding a z. You just needed to find a relationship, a pattern for any one of these triangles that we had. Okay. Here's another example or theorem that we want to look at. Here's a couple of them. These are actually the last two, I believe. So here, notice there's no real triangle here. I can extend these out to make a triangle. That's why this works, by the way. So 3 parallel lines. It can be as many parallel lines as you want. So parallel lines intersect 2 transversals. Then the segments intercepted on the transversal are proportional. So that means this piece to this piece to that piece, or any corresponding parts. Okay, I can do this piece to the whole thing, this piece to the whole thing, this one to the whole, this one to the whole thing. I can do this piece to that piece and that piece to that. As long as you're doing the same pattern, it's going to be proportional. Okay, and so this one down here is another interesting one. And so this one is, I have a ray and it will bisect this angle. So these angles are congruent. And then what it tells me is that the pieces that are created are proportional. That means this side, this piece, and that piece is proportional from this piece to that piece. So these two pieces that are created form a ratio with these two sides over here, proportional with those two sides over there. And any corresponding pieces thereof, okay? So I could have gone in a different direction. It doesn't have to be exactly in that form. these things can form proportions because that's what it's telling you. Because they're going to be similar. All right, so again, just find the corresponding parts, and they are proportional. Let's look and see. I think I have another example here. Yes, I do. I've got two more. Let's take a look at them and see how this can play out on tests that you're going to be seeing. Okay, so here I have the parallel lines. So you got to make sure you have the parallel lines, the two transversals. Okay, then the side piece, the pieces that have been cut are proportional. So you just need to set it up in your proportional format. Okay, you can go 12 over 16. So I went here to here. So then I have to go here to here. So that is x over 13. And then you can cross multiply all this and get your answer. So we multiply this diagonal, divide by that third number. And so x is 12 times 13 divided by 16. And then you can reduce all this out, and you will get 39 over 4. And there you go. Please leave things in reduced fraction form, please. Down here, here's that bisected angle. So then these pieces are proportional. They want you to find the value of x, so we need to set up a proportion for this. And using the same pattern that they gave in the little lessons, you're not going to go this over that equals that over that, same thing. But they say take these two together, so 3x minus 7 over 12. And then it'll be, since I started here to here, I'm going to go here to here. And so that'll be 3x plus 3 over 18. These are two terms. They should always be put in parentheses. It should be automatic every single time you do a problem with this. Cross multiply. So I have 18 times 3x minus 7 is 12 times 3x plus 3. Just write it. Don't try and simplify it until you get it to this format. Then you can distribute and get your numbers and all that stuff. So 54x minus 126. And this is 36x plus 36. Bringing and solving for x. Move this over here, move that over there, and I end up with 18x equals 162. Divide by the 18, and that gives me x is 9. Okay? If x is 9, then what is the length of GH? Well, I just got to plug 9 in for that. So GH is 3 times 9 plus 3, or 30. And what is GK? GK, well, that's 3 times 9 minus 7, or 20. So there you go. And so these are all the proportional stuff that you're going to be doing, which is mainly what 7 is about. It's learning how to find and set up proportions from similar triangles. So that concludes this lesson. We'll do more in class.